right, so when we're finding the given zeros, 3 minus root 5 as well. We write that conjugate down immediately. Okay? And then it becomes x minus 2, x minus 3 plus root 5, x minus 3 minus root 5. Then we have x minus 2. Remove the parentheses. And that's what we've been doing every single time. We set the original problem up, then we're going to move the parentheses. Now I'm going to FOIL between these two parentheses. X minus 3 times x minus 3 is x minus 3 quantity squared. Then it becomes a negative root 5 x minus 3 plus root 5 x minus 3 is the x minus 3 goes to negative root 5, the root 5 goes to x minus 3. And finally, root 5 times negative root 5 is a minus root 25. I'm FOILing here, and that complicated looking part in the middle is always going to cancel out. So we shouldn't have to worry about that. So x minus 2 times, well, the x minus 3 squared does need to be worked out. X minus 3 times x minus 3, which is x squared minus 3x minus 3x plus 9, and it's x squared minus 6x plus 9. Okay? So this becomes x squared minus 6x plus 9, and then the square root of 5 is, or square root of 25 is 5. X minus 2 times x squared minus 6x plus 4. Okay? And then we distribute. The x goes through to all three terms. Minus 2x squared plus 12x minus 8. And we combine our like terms. X cubed minus 8x squared plus 16x minus 8. If you want to check this multiplication here, we can do a quick synthetic division. 1, negative 8, 16, negative 8. Drop the 1, we have 2, negative 6, negative 12, we have 4. 4 times 2 is 8, and that's 0. Okay? Are there any questions with that? All right, so we're going to put negative 1 minus 2i. We always switch that sign in there. So we have x plus 4. We have x plus 1 plus 2i. And we have x plus 1 minus 2i. Okay? Remove the parentheses. We now FOIL. X plus 1 times x plus 1. Minus 2i times x plus 1 plus 2i times x plus 1 minus 4i squared. The middle terms cancel. The x plus 1 squared becomes x plus 1 times x plus 1. X times x is x squared. X plus 1. And the middle term is x squared plus 2x plus 1. So this becomes x squared plus 2x plus 1. We've got to know I squared equals negative 1. Negative 4 times negative 1 is a positive 4. We're going to combine our like terms here. X squared plus 2x plus 5 x squared plus 2x squared plus 5x plus 4x squared plus 8x plus 20. Oops, I'm sorry. Should not be x squared there. Should be what? X cubed. Sorry about that. So x cubed plus 6x squared plus 13x plus 20. And one check I can do is with the negative 4. I know it only checks through the middle problem, but at least it's something. It takes away a careless mistake if I make it along the line. We get that 0, and we have our x squared plus 2x plus 5, the same coefficients. Okay. So, sign change. If there's no sign in front of the term, it's a plus sign. That's a sign change. That is a sign change. No. No. Sign change. No. So we have 3 sign changes here, which means you have the possibility of 3 or 1 positive 0 roots. Okay? 3 sign changes, or you count down by 2. You get to 1. Now I need to put a negative x in. 4 to the negative x, or negative x to the 6, minus 3, negative x to the 5th, plus 6, negative x to the 4th, plus 5, negative x cubed, plus 2, negative x squared, minus 7 times negative x, minus 2. When you have an even exponent, the sign in front stays the same. 4x to the 6th, and that remains positive. 6x to the 4th, that remains positive. 2x squared, that remains positive. And minus 2, that remains negative. I don't care what the sign is in front of the term with the even exponent. 1 second. Don't care what the sign is. It stays the same. When you have an odd exponent, as you do with the 5th, the 3rd, and the 1st, you change the sign in front. This becomes now plus 3x to the 5th. This becomes now minus 5x cubed. And this becomes plus 7x. Now, once I plug my negative x in and make the adjustments to the problem, now I got to count sign changes. No. No. Yes. Yes. No. Yes. So there's 3 sign changes, which means I can have either 3 negative zeros or 1 negative 0. And now I come to my chart. My total zeros have to be 6. My options are 3 and 1 for positive and 3 and 1 for negative. So with 3 positive zeros, I can have 3 negative or 1 negative. And with 1 positive 0, I can have 3 negative or 1 negative. I need to basically put every possible match here. Okay? I need to put every possible match. 3 plus 3 is 6, plus 0 is 6. 3 plus 1 is 4, plus 2 is 6. 1 plus 3 is 4, plus 2 is 6. 1 plus 1 is 2, plus 4 is 6. As I add across, I always have to equal the total number. The sign in front of 3x to the 5th is positive. No. Yes. No. No. Yes. So in this case, there's 2 sign changes, so I can have 2 or 0 positive 0 roots. When I plug negative x in, we have a negative 3x to the 5th. Because the odd exponent changes the sign in front. The even exponent keeps the sign in front. The odd exponent changes the sign in front. The even exponent keeps the sign in front. The odd exponent here changes the sign in front. and it's plus 1. Okay? I don't care what the sign is in front. It doesn't matter whether it's positive or negative. If it's an even exponent, it stays. If it's an odd exponent, it switches. And then we do the same thing with sign changes. Yes. No. Yes. Yes. No. So there were 3 sign changes. So it's either 3 or 1 negative zeros. I have a degree of 5. So all of them are 5. My positive reals are 2 and 0. So 2, 2. The 2's got to go with the 3 or the 1. And then 0, 0. The 0's got to go with the 3 or the 1. And we add across. 2 plus 3 is 5 and 0 is 5. 2 plus 1 is 3 and 2 is 5. 0 and 3 is 3 and 2 is 5. 0 and 1 is 1 and 4 is 5. And that's my answer.